Hi everyone, my name is Jaime Martinez. I'm a senior backend engineer here at GitLab. I work in the Container Registry group, part of the package team. And yeah, today I'm going to be showing you a bit of a demo on how to enable the metadata database for new Omnibus installations. So as you may be aware of, we recently released this metadata database on gitlab.com that allows you to run online garbage collection. So we've been working more recently on releasing this for self-managed installations. And yeah, this is Epic that you can follow along. And more specifically today, I'm going to be talking about this PoC that I've been working on and trying to enable the database for a new installation, basically. And today I'm going to focus on the Omnibus side of things. So I have created a snippet that I will link to this issue at the bottom. And here I set up most of the steps that I had to follow. And I'm going to be following now. So hopefully they'll work on the first try. So cool, let's get started. So first and foremost, this is an experimental feature. This isn't a new installation. So please, if you follow this, it's at your own risk. We recommend this on new installations because there's possible data loss. This is not completely tested for self-managed installations. It's not managed yet. So yeah, just be careful with this. Cool. So before getting started, you can either have a domain name or an IP address for this. I forgot to mention I'm going to be following the GCP installation method. So yeah, I'm basically just following this guide that we have here on Google Cloud. I'm going to skip a few steps here. For example, I already created a VM in Google Cloud. So I'm going to go into step 2, or basically this part of installing GitLab. I'm already connected to my instance, so I'm already here. And let's go into this next step. Is following this guide. I already ran this update and this installing some of the dependencies, so we should be good to go here. So now I'm up to this step where we want to add the GitLab package. So let's do that. Should be fairly quick. Cool. In here, now we're going to install GitLab, right? And we're going to be running this one-line command. Before we do that, I recommend either getting a domain name like specified here or getting the IP address of the instance where you're running. For me, I'm just going to be using the IP address for now, just because it's easy to test. I'm going to copy this IP, and then I'm going to run the command, this one, and then I'm going to change this to that. Whoop, that's not the one. Let's put the IP address. Now, a little tip that I've added to this snippet here is you can use the NIP.io service. It's basically a simple DNS service that whatever IP address you set here is going to result to that IP address. So I'm going to do this GitLab dot IP address and then dot NIP.io. And I'm going to just use the package manager to install GitLab in here. So let's do that. And this should take probably a few minutes. But let's see how we go. One thing I need to mention here is I'm using HTTPS here. This will generate some self-signed certificates, or if we have Let's Encrypt available, it should generate the certificates for us as well. So that's pretty good because when you would do this, some dependencies or some services like the registry will be enabled by default. So yeah, it's just a little bit easier this way. I may pause the recording here and wait for this to come back. All right. Okay, so the installation has completed. As you can see here, we have a hostname now. We should be able to log in here. I'm going to have to get the password. So where is the password? Didn't set up a password, but initial password. Here it is. All right, so we are now inside the GitLab instance. Let's just do this real quick. Disable signups just because it makes it easier. Following the practice. Cool. So now that we have this, we can probably skip this. We just want a simple GitLab instance that is running. And we are gonna create, I'm gonna get ahead of myself. I'm gonna create a sample test project. So let's just call it registry. Let's just say it's private, create a project, and we're gonna see the container registry is enabled. So cool. Before we start pulling and pushing things from the registry, let's not do that yet. Let's follow this part here. Cool. So we're gonna do these preparing steps. So first, before we start, let's just make sure we have a backup of the GitLab registry. GitLab configuration. Although to be honest, the rest of the configuration only has the external URL because it's the default one. But anyways, we should still err on the side of caution here. Okay, this didn't work. Yeah, we got a copy of the file. Cool. So what are we gonna do? We're gonna first create a database user and then create a new logical database inside the Postgres instance that GitLab comes with. If you use a separate instance, or if you like to use a separate instance, the process will be similar, but the commands will be a bit different. But the queries will be the same. So here, Omnibus provides this GitLab PSQL tool that allows you to connect to the database as the root or as the owner of the installation. So this allows you to create users and databases. So if I run this created a user with a password, and as you can see, it's created role. And then I'm gonna say, okay, registry, create database. Cool. So now we're done with this part. We can probably verify this if I do GitLab PSQL, and then I just say do du. This should give me the users. And as you can see, there's a registry user in here. After doing this, we need to make sure that we allow local connections using username and password. This is because the default, the default configuration for the Postgres configuration that comes out of Omnibus only allows local connections via sockets, but we need to allow, it doesn't use password, it uses a peer connection authentication. It's a little bit out of scope. So for now, what we want to do is we want to allow local connections to a certain database from a certain user using MD5, which means using a password. So I'm going to copy this, and then I'm going to put that basically put that into the GitLab RB. Gonna put it at the end of the file. Cool. So we can verify this if we go and say, show me the GitLab config. Sudo. Cool. So we are here, and it's all at the bottom, which is cool. Now that we're here, we need to reconfigure GitLab. So we're gonna do this. And after reconfiguring, we need to make sure we restart Postgres as well, so that the settings are applied. So this should take just a minute because we only changed the Postgres config. Awesome. Now we're gonna do a restart of the Postgres instance. Cool. Postgres is running, so we can verify that Postgres is ready by tailing the logs. Yeah, database is ready to accept connections. So now we're just gonna verify that the entry is properly set in this file, the pghva config. So if I do this should give me the few lines. Yeah. This basically says the type of connection is local to this database for this user. And we're skipping the CIDR address for this method because it doesn't need it. And it's all there. Awesome. So we are ready to connect now. What do we need to do? Next, we need to configure the registry to set the database connection settings. So first, we are gonna have to stop the registry. And we're gonna say, okay, sudo GitLab control status. You can see everything's running except the registry is now down, which is good. Also, let's make a backup of the config just because. Okay. And now we're gonna do something similar. We're gonna append the new config, the database config, to the registry config. In this case, you can see here, this is documented in the registry repo. But for now, you can see the settings we need is we are setting the database, enabling it. We're using the host, which is the Unix socket address. We're using the registry user, which we created above, which would be here, with the password, which is just registry password, very safe. And then we're using the same database. And for the sake of testing, we're disabling SSL connections. But if you want to, you can also set up the SSL certificates, the client certificates, so that you can verify you're talking to the database you want. Cool. So let's do this. We're gonna append to the end of the file to the registry config. Now we can see it's all here. We can verify this. We just do. Cool. We can see all the registry config here. It's all running there. So now that we have this, there's one important note that I set up here, because this is not ready to be used by Omnibus, right? The problem is if we ever need to do a reconfigure of GitLab, the settings will be gone. So while we work on that, on adding support for this, I would suggest copying this, the current config, and just name it database config. Then just make a copy. Whoop, there's a typo here. There you go. So if I ls here, yep, I should see some of the config is here. So yeah, if you ever need to reconfigure, I would, after reconfiguring, you should stop the registry, replace the config and then start the registry. And make sure you don't push any new images to the registry, because that will write them to the wrong location. And this is part of the risky bit where you may not be having what you thought you had in your registry. So yeah, just being super aware that this can happen. Cool. Now that we have done this with the registry, we were here. We stopped the registry. We have the configuration. So we can just check GitLab control status. The registry is still down. That's good. So before we start the registry, let's make sure that the connection settings are working. So the registry binary already comes with the database subcommand that it needs to talk to the database. So in this case, we're gonna check if the schema migrations have been applied or not, and just see what the status is. So basically, we call this. Cool. So as you can see here, we have a list of migrations. None of them have been applied, which is what we wanted. But that's good, because it means the registry can actually talk to the configured database. Awesome. So now we are here. We are at this step. Let's run the database schema migrations. So we're using the same command. We're just changing the status to an up, which means run the schema migrations in the up direction, or all of them up. This allows you to run the migrations down. This would undo any changes, but this is out of scope. So for now, let's just do a migrate up. This would take just a minute while it creates things. If this seems to have worked, this says applied 133 migrations, which is all good. And let's check the status. Awesome. So as seen here, all the migrations have been applied. All the timestamps are here. So we're all ready to roll. So now that we're done, let's start the registry again. This just takes a few seconds. Now that it's up, awesome. Let's check the the registry logs. Let's just make sure that this is running. I'm just scrapping for the metadata. Let's add a few lines before. Awesome. So yeah, we see the shutdown before we stop, and then this is a new starting of the registry. So as you can see, we have a message, a warning here saying the metadata database is experimental. Please don't use it in production yet. Feel free to experiment with this. Cool. So the registry is up and running, and it's using the database, and this is great. Now on this tab that I have here, I didn't put this on the guide, but what we're gonna do is just connect to the Postgres console to check that the schema is empty, that the database is empty. So experimental registry. I'm just using the same command to connect to this database. If I do backwards /d, that should give me all the tables which were created by the schema migrations. So if I go and say select all from the repositories, it should be empty. This is good. This is what we want. So now that we're here, we should be able to push an image to the registry. So in order to do so, let's go to the GitLab instance. We're gonna first create a test project. In the instance, I've already done that. This is the instance that I'm working on, and this IP address here. And I just created a project on the root, which is an admin user, and it's called registry. And I have that. The next step is actually creating an access token. So we need to create a personal access token with the API read registry and write registry scopes. So let's do this. Let's go to preferences, access tokens. Let's just call it registry path with API read and write repository. Feel free to remove expiration dates as you need to. Once that we have here, so I have a token. I'm gonna go into a new tab, and I'm gonna just export this token. Cool. So now I have a token somewhere. Did I lose this? I think I lost my tab. Here. Awesome. I have a token. Now that we have a token, let's create a container repository in the instance. Sorry, not create a. This is poor wording. Let's go to the project that we just created, which is verifying that the registry is there. Sort of did that before. Container registry here on the left-hand side. Deploy container registry. These are the details for my instance, which is it's all good. Now let's take a note of this address. One thing that I forgot to mention when you install GitLab with HTTPS, that will enable the registry on the same address that as we use as the external URL, but it's just using the port 5050. This can be changed, but yeah, that's a bit more advanced configuration out of scope. But here I'm pointing to the documentation, to the admin docs if you need to. Okay, so now that we have an access token, we need to authenticate with the registry before we can actually push. If you try to push, it's not going to let you because the project is private. Even if it's not private, writing to the registry, you still need to authenticate first. Cool, so we have a path, so we're going to log in and we're just going to say Docker echo the path. And we're gonna do Docker login. I grabbed the address from the project container registry page. This, you should be using yours. Then, and we're just gonna say we're user root, and we're gonna say password std and in. Hopefully this will come back with a login succeeded. That's good. If we go back to the logs, we should be seeing here some logs, authorized requests, which means we were logged in successfully. So it's all looking promising so far. Now we're gonna pull, we need to get a Docker image. We can build one, we can pull and tag. For now, I'm just gonna pull an Alpine image from Docker Hub, probably the easiest thing to test. Then I'm gonna tag this image as a new image. Where is this? And we just need to make sure it's the same name as here. So let's just do this. Docker tag latest registry. If I just set like this, it's just gonna do the infamous root image. Now we've named it. Now we use the name of the repository, if I remember correctly. So if I go, I'm just gonna do this latest, and I'm gonna push. Should be ready to push. Docker push this. Great. As you can see, the push was very fast. And if you were tailing the logs, you can still see that we're doing some pushing, and it's all created. We have a 201 somewhere there, which means it all worked. Cool. So if I refresh this page on the left side, I should see the image now. Yay. So it's here. If I go into it, I can see that there's one tag. I can do things like tag another tag, and then I'm gonna push another tag. This was very quick. This is because the registry node that the layer already exists. I didn't change anything with the image. So we basically just mount on whatever existed there. If I refresh here, I can see both tags, which is great. Cool. So now that we have this, if we go into this into the database, this is all part of the scripts over here, by the way. Verifying the database. So it's just what I did, connecting to the instance. And now we're just gonna do select from repositories because we can wanna see that this exists here. Select from repositories. And yes, as you can see, the path is basically the name, the project path, and the name of the image is registry. And you know, if I do some joins and here and there, I should be able to get all the data related, all the metadata related to this image. But because this is empty right now, if I do select from tags, I should see both the latest to the repository. Let's take a note of this. It's repository ID #1, top level namespace ID #1. So if I go and select all tags, there should be two. One is latest and one is another tag. And as you can see here, top level namespace ID is 1, repository ID is 1. So they're all match the same ID. Yeah, so that's pretty much it. Now that we have this, for the sake of completeness, we should verify that we can pull. So let's delete one of the tags that we just created locally, not from the registry, but locally. Let's say Docker RMI, another tag. This basically just untags this. It's a bit of out of scope, but if I do Docker pull, because it still exists in the, excuse me, this exists in the registry database, this should be ready to pull. Awesome. So I download it. And again, if we look at this, we see an access 200. You can see in all the logs it says getting manifest tag from the database. So all the operations are going through the database. We also have online garbage collection running here somewhere. If you look at the logs, we see registry GC worker is removing blobs. So all these little features are enabled. And yeah, this is, like I mentioned before, this is just a proof of concept. It's working. Yeah, this is very manual. There are still so many risks. So yeah, just be mindful of that. But yeah, all in all, this is working. If you try this out and you have some feedback, please post it in the epic or in the issues that I'll link to the video. And yeah, let us know how you go. All right, thank you so much.